Hi, we'd like to welcome you to another in a series of webinars designed for departments of transportation. I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri, and today I'm joined by Gary Waters, who heads our transportation sales team, and Eric Rodenberg, who's a solution engineer on our transportation team. So today's webinar, a very popular topic within the DOT community. It's really looking at the data integration within a DOT. How do we bring GIS and survey data really into the design process? And how do we begin to break down some of those historic barriers? Because historically, there's often been a strong separation between the GIS world and the design world and the DOTs, but certainly from our perspective, I think we're all trying to break down those walls and look and really sort of see how we can improve our workflows and how we can be more efficient in our processes to plan, design, construct, operate, and to maintain our infrastructure. So this webinar is designed to highlight really one part of that information flow. So before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for question and answers at the end of the presentation. You can type your questions into the question box, and we'll try to answer as many as time allows. Additionally, the slides that are part of this presentation today will be available to you on the GeoNet group in the departments of transportation, and we can give you that link. So let me start off with some what I guess I would consider rather unpleasant facts about U.S. infrastructure. We actually have the world's highest costs associated with building new infrastructure. As any number of studies have pointed out, we're simply not getting the appropriate bang for our buck with respect to our infrastructure investments. The study on the right that was presented at the Brookings Institute highlighted that in just 20 years, the cost of building 1 mile of roadway actually tripled. And our labor productivity over the last 20 years has continued to decline. And obviously, there are many reasons for this, but certainly technology does play some role in that. And that was really emphasized by a study that was released probably about 14, 15 years ago now by the National Institute of Standards and Technology. And they interviewed a large number of architectural and engineering firms at the time, really looking at kind of the software, the technologies that they used, and ultimately focusing on the difficulties and interoperability between these different software platforms and programs that these companies would use to plan, design, and to construct and deliver infrastructure. And obviously several findings worth pointing out, probably the fact that, if we really had much better data and information communications, that in fact that could really reduce the project delivery time by 20 to 50%. And that the fact that there was this poor interoperability, poor communication between these different systems, that in fact that wasted up to 30% of the project costs. And probably the most telling was that if we would take our information systems seriously from the very first stages of the project and think about how we're going to manage that information as it flows through the infrastructure lifecycle, that in fact we could save up to 14% of those O&M costs. And as anyone will tell you, O&M typically represents about 70% of the total project's budget. So really quite significant savings potentially if we think about how we can do a better job. And so that really highlights, I guess, what I would call the whole life cycle information management, that we need to think about how we manage that information really from the early planning stages through design into construction and then into maintenance, operation and maintenance. And if our current practice all too often is that at each stage we start over with information, we rebuild different systems, different software. But if we had a way of more seamlessly or in an integrated way thinking about how we manage that information, those are the potential savings that are available to us. Certainly, I think we at Esri are focused on how do we break down some of those barriers. In Europe, I guess I would have to unfortunately say they're much further ahead of us on that. What I would call whole lifecycle information management, they really call BIM. And BIM in Europe is not just the software, not just the design, but really is that how do we manage the information through the entire project lifecycle? And it's actually become a requirement on large projects in the UK, and really in most of the European countries. It is actually a federally or nationally mandated requirement that the contractors follow BIM standards. And in the UK, they really, the goal is that they want to really have it result in construction savings of somewhere in the neighborhood of about 20%. I think the jury is still out in terms of whether they've actually hit the 20% in all cases, but certainly that's the goal. And certainly the evidence to date certainly shows tremendous cost savings and return on investment. We in the U.S. have certainly there have been this particular NCHRP report really focused on what at the time was being called Civil Integrated Management, CIM. In today's world, we really talk about it in terms of BIM for infrastructure, but clearly federal highways and AASHTO and TRB are really trying to advance this concept that how do we in the U.S. Adopt these methodologies, these practices, so that we can begin to, again, be more efficient, more cost effective, and how can we do a better job of managing that information through the life cycle. So with that, let me turn it over to Gary to sort of give a little different view on the integration between GIS and BIM. And Gary, take it away.
Thank you, Terry. Yeah, I'm going to start with a little bit of a different depiction of the asset management lifecycle that Terry was referring to and talk about the specific technologies that usually support this. And as Terry mentioned, trying to get information flowing around this entire asset management lifecycle is challenging at times. In fact, my diagram kind of very clearly points out two specific points in the life cycle where that data migration or data movement, data access becomes very challenging. We traditionally have had a hard time getting design data over into the operations and maintenance modes and then coming back around the other side from planning to help feed data for design purposes. So I like to look at this diagram drawn even a slightly different way because I think it helps reflect the fact that there are almost two distinct life cycles that go on. Within a project, you usually have the survey, CAD, BIM, design information, and then for your operations, maintenance, and planning purposes, typically there's a whole another set of a life cycle. But they are interconnected at those 2 points that I showed in this previous depiction of the asset management lifecycle. I've put a few vendors over there on the side that we find traditionally involved in that design construction environment. Certainly they're not the only 3 people that play in that market space, but certainly very prevalent and a large presence in there. Today's demonstration, when we get to Eric, will show a lot of the advancements that we're making in partnership with Autodesk. But while the exact ways we interact with Autodesk are not available in the Bentley MicroStation environment, the concepts of how this data should and could be moving around the asset management lifecycle are certainly consistent. If you look at getting out of that construction phase, and Terry alluded to this about operations and maintenance consuming a lot of time, effort, and financial resources, and typically you see the GIS component. So if we can get data effectively out of the design and construction phases into the operations, maintenance, and then eventually into the planning sides of things, it will tremendously help us with reducing costs and overall challenges. Again, on that operations, maintenance, and planning side, lots of performance measurement analytics that get used to help determine how our assets are performing and where we need to make our future investments in projects. I think one of the things, and another term that we're starting to hear a lot more of, is this concept of a digital twin. And the Esri geodatabase is capable of being that digital twin storage environment. And you're going to see in Eric's demonstrations today the use of the geodatabase to basically store information in a manner that makes it accessible and usable by every portion of that asset management lifecycle, which is critical, and starts to highlight how this information can seamlessly and with zero loss move throughout the entire lifecycle. The other thing that's interesting about the digital twin concept that you hear more about is I often hear it only referred to from a data standpoint. And I think one of the most critical things about creating an ArcGIS digital twin is we have all of the functionality that you need, all of the analytics to help make that digital twin really be a digital twin. The thinking processes that you would associate with that data can be captured and performed using the ArcGIS platform. And with that, I'm going to turn it over to Eric and let him show you some of the things we have. Eric, I don't know if you're on mute.
There we go. Okay. So I'm going to start by just giving you a quick overview of the workflow I'm going to be doing today. So Gary, can you see that slide? Just making sure I'm okay. Perfect.
No, I see your desktop still.
Your desktop.
How about now?
There we go.
Yes.
Okay. So I'm going to be showing you a workflow today where I take data that was provided to me by Trimble through Trimble Business Center, and I'm going to take that data, turn it into or that data was provided to me as a file geodatabase. So Trimble has the ability to export data that was collected via their devices through their devices, export it out to file geodatabase or enterprise geodatabase. And then I'm going to take that data that was given to me as a file geodatabase and turn it into a feature service through ArcGIS Enterprise. I'll actually be using ArcGIS Online today, but we could use ArcGIS Enterprise as well. And then I'm going to show you how we can take that data into Civil 3D and actually utilize it, edit it, pass it back to ArcGIS Online, and interact with it through all of my other clients as well. So for instance here, I can take this data once it's collected and make use of it in mobile apps, in dashboards, in basically any type of app that Esri supports, and then also utilize it in Civil 3D to do work against it. So this would allow us to do things like inspections and notify the design group that the condition of those inspections. The design group can also provide us with the locational accuracy of the data collected in the field, and we can better align our assets to overlay with what's actually captured in the field. So There's a lot of interesting workflows here that I'm going to be showing, but that's basically, we are going to be focusing on taking the file geodatabase up into a feature service, and then once it's in a feature service, I'll show you how we interact with it through all of our apps. So let's go ahead and get started here. Taking this further, I'm going to show you the database that Trimble gave us. And you'll notice here, for instance, if we look at this, this geodatabase they gave me, there's 426 layers in it, and these layers are broken out in many cases by the layer name and then an underscore 1 through 4, all the way up to 8. I've seen as many as 8 here, like on the subterranean layer. Basically, when the surveyors are going out, they are taking all their shots, and they're, if we're working on a 2-mile project and the project runs east-west, they're working the north and south side of the road, taking all their measurements. So if I'm collecting sidewalk, I'm just moving back and forth, going up that 2-mile stretch of road, getting everything I can get as far as I'm gonna go. And some of these projects are much larger. They can be 10, 11, 12 miles long. And so in that case, they'll deploy multiple surveyors to go out and collect data. And these surveyors write this data into various layer types, which is fine. It works just fine. In CAD world, they don't have the notion of layers like we do, where we store like items together, like in the case of striping. But we can easily take that data that Trimble gives us and basically collapse it down into a single layer. So instead of me having 6 striping layers, I can get this down to 1. And it's going to be a necessary workflow to do in order to make this data available on the web and optimize it for performance. Trying to take a database full of 426 layers and use that in ArcGIS Online or even in ArcGIS Enterprise isn't very practical. It can be done, but it's not practical. So we've written some scripts that take that data, and we figure out which of these layers. Not all of these layers have data in them either, so that is another challenge. So I've written a script that goes into these and loops through, finds all the data, all the layers that contain data, and then simplifies the list. So I took this down from 426 layers to 48 layers, which is a much more manageable number. And in the process of doing that, I preserved where that data is coming from. So you can see here, I preserved, when I collapse this data down, what layer each of these stripes came from. So we have bike lane, we have double yellow lines, we have lane lines. So I know exactly what layer each of these came from. So if I have to give this back to the field guys, I can blow it back out into the respective layers because I know where everything came. And so that was a key component to this. So then with that, let me take you through the data that we've uploaded to ArcGIS Online. So this is currently the data I'm working with in ArcGIS Online that was given me from a field survey, but the survey crews recently notified us that that this data has been updated. And so when we look at the comparison tool here, and I just slide the slider, you're gonna see right off the corner of this building, a survey point was added, and then you're gonna see 2 edge pavement lines are gonna show up when I drag the slider. So let's do that. So you can see there's that survey point, that control point, that as stake point with an ADD nail. This is a construction feature. And then we've got this edge of pavement feature. So this data is changed. It's not current. So I've got another script that I'm going to take to automate the process of taking the data that the survey crew gave me and overriding this service with the new updated data. So I'm going to run that now. And while that's running, we're going to go over to this view and just hang on here for a moment while this data runs. And in a moment, you'll see this point pop into the map. We'll see the edge of pavement pop into the map. And what's happening is I'm taking the file geodatabase that Trimble gave me, I'm packaging that up into a zip file, and this is all happening in Python. I'm packaging that up into a zip file. and then I'm logging into ArcGIS Online programmatically, finding that item that I'm going to overwrite or update, and then take that geodatabase, and there it went, just zipping that geodatabase up. And we're going to take that geodatabase and overwrite this feature service with the new updated data. So we're going to see that data update in real time. And this is important because the geodatabase and the feature service are acting as that central repository, that system of record for all that survey data that was collected. And then once that survey data has been collected, we could take that data and incorporate it into the asset management. We could incorporate, like I said, we could take, if we see that we've got data that's not located correctly in our asset management system, we can use the survey data to correct it. We can do inspections off of this data. We can provide contractors who are in the field with a real-time view of the same data that the surveyors are working with, so, or what the design group is working with, rather. So all this data that I'm uploading right now, we're going to be able to utilize it and view it in Civil 3D. We could view it and work with it in InfraWorks, which is more of a conceptual design tool by Autodesk that's doing work with modeling of timings of interchanges, of traffic modeling, whereas the Civil 3D product gets into the digital or the detailed design.
Well, and Eric, the beauty of it being in ArcGIS Online or ArcGIS Enterprise is you're showing a very specific survey, but if you add the neighboring projects from this, all of that data would be visible as well in this view.
That's right, Gary. And you can see here just before our eyes, the survey just updated. So we now have the edge of pavement, and we now have that as stake point. So just a minute ago here, we are updated. And Gary, to your point, that's right. Being able to seamlessly look at all these surveys now and combine all this data together in one central repository, it's a powerful concept that is going to allow us to further the workflow. So with that, let me take my phone and I'm going to launch into Collector. And I have a map that we're going to take a look at that is going to specifically look at the signs. So if I zoom in a little bit here on the web map behind my phone, you can see there are some signs here. Well, I want to go out and I want to inspect these signs. So I can come into this map and I can click on a sign, for instance, and we want to go ahead and we want to just make an update to it. And you'll notice here, if I stop what I'm doing, well, we'll go back to it again. When I go into edit this point, it only gives me the ability to edit the condition. So I'm going to submit that condition. And in a few minutes, well, we'll see on the dashboard here, if we go into the condition dashboard, you'll see in a moment this sign is going to update from green to yellow based on the edit I just made. And then this guy, and you can see there, just took effect. Now you can see here when I go to select this sign, it shows me lots of different attributes. I see this, I see material specifics, height, diameter, and I could capture all this information in Collector. I could capture all this information in Autodesk. I probably could have captured all this information in Trimble. We have links to photos. We know it's a sign, it's part of the traffic control layer. But when I go to actually edit it, I've limited it to only do the inspection. So that person who's out in the field can only inspect this. They're not going to be able to move the feature, edit the feature. They'll just be able to mark up what's going on with it. So I'll get that submission. And now we see that in my Collector app, the sign is reflecting the red condition of poor. And in a moment, the dashboard will also catch up to that and reflect it as well. So we see in real time this ability to capture this information and report.
And Eric, the ability to control not being able to use those collector tools to move the sign preserves the accuracy levels that were captured through the survey process. So I know a lot of times I have discussions with people who are concerned about GIS data because they say it doesn't have the same level of accuracy. Well, that's not because the GIS is incapable of storing accurate data. It's because it gets created by someone's phone instead of survey equipment. So you have the ability to really preserve that rich, accurate survey data.
Yeah, and you know, you're right. I mean, a theodolite is probably going to, you know, depending on the type of theodolite I might be using, I might be able to get sub-centimeter accuracy. With my phone, really the best I'm going to be able to get is just with the phone by itself, probably at the best 16 feet. And if I add in a GPS adapter, I might be able to get that down to 9 feet, which may not be good enough. So taking this further, we've just updated these records, and you know, I could do the same thing with the other features. We have striping, we have culverts, we have curbs. There is all kinds of data. There's a treasure trove of data here that could be updated when you look at this. So you see here in my map, we've got a culvert crossing the road. We've got the striping. So I could go into my culvert as well, and I could update its condition. So we'll go ahead and we'll do that real quick. We'll mark the condition of this to be poor, and we'll keep current values, submit that, and we'll give it a second there. And while it's doing its thing, I'm going to switch over to my, while that update's happening, I'm going to move over to my virtual workspace. And by the way, when I was doing all these edits, I should point one other thing out real quick. I was logged in as a different user. So the whole time I was doing these edits, if we select this point, there we go. We see that the point was inspected at 124. It was actually inspected by DOT dispatcher. So I was logged into my phone as a different user. I wanted to show this. Now I'm going to go over to my virtual machine. I'm going to pull all this data into Civil 3D. So let's go ahead and do that. So we're in Civil 3D. I've already set the projection of the map that I'm going to be working in to NAD 83 California State Plain Zone 2. So now what I'm going to do is I'm going to go over to the Insert tab, and I'm going to connect to ArcGIS Online. So using the Autodesk connector, this is going to log me in, and you can see I'm logged in as myself, as Eric Rodenberg. I'm going to search for Sacramento. And there we go. So now I selected this polygon tool, which is going to select the current map extent for Sacramento, and it analyzed my content in ArcGIS Online, and it sees all of my groups. So I'm going to go into my groups, and I have a group for this Caltrans California Survey and Asset Collection group, and I'm going to go ahead and pull in the data that we just updated. This is the service. We'll click on it, and when I click on it, it's going to interrogate it and find all the layers that we were just looking at. And now the unfortunate thing here is it doesn't add these in order. So I'm going to have to go through some of these and just make sure I'm grabbing the right components here. So we want our drainage inlet. We want our signs. I would like to get the asphalt edge. There's my sign points.
So Eric, while you're selecting those, this is really an interesting concept, because the data that's coming to you is through web services, which really facilitates the integration and the assurance that we're sharing the live data among all of the different clients. Whether you're doing performance management or planning or design, you're working on the same data, which is really critical. And it really highlights how the geodatabase and this concept of web services fulfill that goal of zero loss, seamless sharing of data around that whole asset management lifecycle.
Yep, that's right. And so it sees I've got 6 layers selected. I'm going to add these to my design project, and it's going to download those as Civil 3D objects. So in a second here, I'm going to get a dialog that asks me to map certain attributes. So I marked my gravity points as culverts, I marked my culvert lines as gravity pipes, rather. Sorry, I have that reversed. So from here, what I can do is I can actually map the gravity points to attributes in my service. So for instance, my service is carrying a diameter. If it were carrying an internal diameter, a pipe width, the wall thickness, if all those measurements were present, I would be able to map every one of those measurements so that when it renders that gravity pipe, it does it in accordance with the attributes I'm providing from each individual gravity pipe. Same thing goes for my signs. Now I marked my signs as structures. I probably just needed to do those as COGO points, but you get the idea. So I can go in here and I can map the attributes from my GIS to those Civil 3D objects. So then once I'm done with that, it imports that data, and it's going to bring it into the display here. So I am looking at objects that came over from ArcGIS Online in Civil 3D. Now let's give this some image in the background. In the near future, I will be able to bring in imagery from ArcGIS, and of course I could bring in any other GIS layers that I have access to. So if I had access to roads and highways data, if I had access to other asset data that maybe wasn't managed in roads and highways, I could bring all that data in here and visualize it along with the data I brought over from Trimble. And so looking at this, I updated this sign. So if we click on it and we go into the properties of this sign,
I just wanted to point out the fact, Eric, I love watching you do an Autodesk product demonstration.
It is a little bit different, isn't it? So you'll notice here in the properties, oh, I just lost it. You'll notice here in the properties, this extended data tab, here's all my data about the survey. So you can see there the condition rating for that second sign, I made it average. This sign here I made poor. So when we identify this guy, he's going to show up as poor. So if we look at the extended data again, I can see that this sign is marked poor. So that's based on the inspection I did. And you'll notice here, it captured the DOT information. Now, because I'm logged in as Esri DOT, we're seeing that it brought in my specific attribute information on the creation date. So it considers that pool of data from ArcGIS Online as almost like an edit, and has marked it as such. So I see all these attributes. In a future release, Autodesk is going to give us the ability to actually edit these attributes. Currently, they're read only for me. So at the moment, I can read these. I can't write to them. And of course, I can do other things as well. So looking at this edge of pavement, if I wanted this to follow my edge of pavement closer, I could go in and start editing this edge of pavement data directly inside of Civil 3D. So taking this concept, we're going to go ahead and completely change this data look based on what we're seeing. Okay, so we've got our edge of pavement. I'm going to update this line as well, get it down here to the fence post. And then once I'm done, I'd like to push these edits back. So I'm going to go back to the Insert tab, and I'm going to go to the Data Store Manager. Let's close you out. There we go. On the Data Store Manager, I'm going to save this data back to ArcGIS Online. Now, the only thing I really edited here was the asphalt edge. I could uncheck these other boxes and not update any of these items. I didn't really do anything with them, but I could, if I did update these, I could push updates out to all the layers, but I only really updated asphalt edge. And even if I left them checked, it's only going to update the asphalt edge because that's the only thing that changed. So let's go ahead, let's save back. And so it's writing back the asphalt edge to ArcGIS Online. And now if I go back to my desktop and we go to my survey, here's another dashboard I have tracking all the changes that are made to the stake points and the asphalt edge. You can see this asphalt edge just changed and it just updated. So we're seeing that asphalt edge, and I've got a filter on, so the selected record filtered the other one out. Now, if I click on the other one, we can see exactly what changed, and I could turn on the aerial photo, and I could see in Autodesk exactly what changed, how it changed, and really Autodesk, Civil 3D, InfraWorks, they just become another client to ArcGIS. I can edit features there, push those back to the GIS. I could even pull in GIS features. So I might have some assets that were collected in the field, and we just want to go in and do some validation on that. I could do some of that validation, incorporate that into the design, and do that all inside of Autodesk, pulling in GIS layers, using them potentially as a backdrop, or bringing those GIS layers in and literally loading them in as Civil 3D objects that I can then manipulate however I need to. And then, of course, when we have the ability to create new features and edit attributes, that's going to open up things even more to where Civil 3D becomes a full-fledged web services client to ArcGIS Online and portal for ArcGIS, and can write data back and forth. Any questions about any, or I guess, Gary, do you have any comments there?
No, look good. It shows true interoperability between the Autodesk environment, Trimble environment, and Esri.
Yeah, and then let's see here. We got one last thing I want to show. This is a pretty interesting, actually, before I do that, let's take this one step further. So in my slide deck that I showed at the very beginning, one of the things I touched on was being able to get this data back to the ground. So if we take this last slide here, I talked about being able to edit this data in Civil 3D, edit this data in our mobile apps, and it all lives in feature services. Well, I can suck that feature service back down to the ground as an enterprise, into an enterprise geodatabase or into a file geodatabase. And so I've got another script I'm going to run here, and instead of talking about this, let's just get to it. I'll execute this export. Which is going to go into ArcGIS Online again. It's going to package up all that data that I just edited, and it's going to download it. It's going to download that feature service as a file geodatabase, and so in a moment here, you'll see as this script runs in the background. I've got it running on my other screen. As it runs in the other screen, and I can even pull this in, we'll see some messages pop up here as it goes. as it runs, kind of pay attention here to the bright blue that's going to start to appear. As this script, it's logging into ArcGIS Online as me. It's going out and finding that feature service. It's downloading, and it's going to download that file geodatabase. And then once it downloads that item, it's going to zip it up, pull it down, stick it in this downloaded file geodatabase folder I have open. And in a moment, you'll see that file geodatabase come down and get downloaded. And then once it's downloaded, I can unpack it. I can start using it. I could use it in Pro. I could push it out to Trimble Business Center so that my guys who are going out in the field have that data. So there you go. It's downloaded now. It actually unpacks it for me. And now I'm just going to go out to that extract folder through Pro. So if we go into Pro, we'll go into my downloaded file geodatabase folder. I'm going to refresh this so it picks up the new data. And there's the data that I just worked with a few minutes ago. Now I could have downloaded the whole thing. I just grabbed the acetate points. I grabbed the asphalt edge. Let's grab those signposts because that's what we worked with directly. We actually worked with the signposts and the asphalt edge. So we'll take a look at both of those. If we go over here to my condition field, somewhere in here, there it is. So we see my condition. We marked one as poor, one as average. So those got collected appropriately. The editor tracking, of course, picked all that up and marked the things that got edited. And then we also have the asphalt edge, and we can look at the geography on that to see the edits that I made got pulled back down to the ground, and then we could take those edits out into the field through Trimble Business Center, importing that data back in and loading it up as in the feature content library, so those guys can go out and shoot more and collect more data.
So Eric, the purpose in creating that file database that you just did would be to pass this data back to the Trimble units through the Trimble Business Center.
Yes, correct.
Yeah. I mean, because to just access the data in Pro or Collector or Dashboard, you would have just hit the services that were already published through ArcGIS Online. So you were getting data back into the survey environment, yeah, with that process you just ran.
Yeah. Now, another interesting process, Gary, that we could do off of that as well, and this is kind of an interesting thing. So I'm going to pull up my workspace one more time, and I have a DWG here from Alaska DOT. So we could take a DWG like this, and we could do validation on it to make sure that it meets the CAD standards, right? We could take, so if a consultant gave me this DWG, I could run it through on the output tab in Civil 3D. I have the ability to publish this out as a service. So I can take this data and I can publish out the alignments. So I'm going to connect into ArcGIS Online again as myself. And then the dialog is going to walk me through what it needs. So it's going to write out these point groups, and then it can write out my alignments as well. If we were carrying things like gravity mains, if we had offset alignments, curve alignments, rail alignments, I could bring all those items out as well. We're working on better support for those items in ArcGIS Pro. I know that that's going to be coming over the next couple of years as we work to improve direct read at Civil 3D in Pro. But we can take this data and publish it out as a service, and then we can validate that it's got all the components we need. So I'll go ahead and click OK to that. And then the publish dialog is going to pop up. And honestly, the published experience is very much so like ArcGIS Pro's sharing experience. It's going to ask me for a title. It's going to ask me for tags. It's going to ask me for the summary. So all the same things are there. It's going to ask me for the extent that I want to include. So it's a very similar look and feel So when you're thinking,
I was going to say the workflow, I hear people talk about how much time and effort they've spent producing CAD standards, but they consistently get data submitted to them from outside contractors. Even their own design engineers will violate those standards sometimes. And this is showing how you can take immediately in that AutoCAD or DWG data, and you could run those validation checks. And because of the spatial capabilities, if we saw a centerline file, that a center line that broke and it suddenly went to a different layer or level or line type, we would note that, and we could tell that it probably should have been a center line, but it was miscoded as an edge of pavement, and report that kind of stuff back, correct?
correct. So we've got, I'll give it a tag here. I can go into the advanced settings. I can choose, I can make this an editable feature service. I can determine who I'm going to share this with. So I could share this with everyone, the DOT. I could share this with a specific project group. So again, contractors, even internal employees, I want to review the data that we created. I want to get access to it in GIS and take advantage of the location of some of this data. Like in terms of the points, we might have some water inlets or some drains that we want to capture in GIS, or we want to capture locations of signs, and I want to get those XY coordinates and whatever data is on top of that data in CAD. We can immediately publish this out to ArcGIS and then start to leverage that. So there's a lot of interesting opportunities here. So let's go next. And it lets me pick, of course, where I'm going to publish. I'll just publish this into my content. And this is going to take a minute, so we'll let that just go. But basically what you get is a CAD file, the result, and I've already done this earlier, so I'll show you what I did earlier. The result here is, here's my Douglas Highway. And I haven't symbolized these points yet. I haven't gone in and symbolized the alignment and the points yet, but you get an idea here. I could go into the points and I can uniquely identify these by their description or their name. There we go. So we see the description type, and a lot of things got classified into other. That's the smart mapping is a little too smart for me right now, and it is putting everything else into other, but we could blow these out. So, or if I just wanted specific things, I could filter. So if I was really only interested in the signs, I could pull the signs out and then start working with those. So here I think we have signs in here somewhere. I probably need to go to an intersection to really get what I'm looking for, but or just filter some of this data out into other. There we go. And then we can make our sign a different symbol type. Could have made those bigger too. And there we go. So there's our sign. So it doesn't give me too much more information than that, but I've got a latitude, longitude, and then an elevation, which is perfect. So if I can figure out later from the asset management what exactly that sign is, but we've got a location, and we can compare this to the location we have on the asset and actually improve that asset's positioning based on what we have here, or report back a condition to the designer and note to them that, hey, we probably need to replace the sign It's at the end of its life. Let's replace it. Let's mark it for replacement. We've marked it for replacement in the asset management. You guys need to know. And here's the latest condition ratings on that information. So it's just a way for us to collaborate better and work together more closely. And really, that's all I have to show for today. I really wanted to highlight the ability to take a file geodatabase from partners like Trimble, from the GPS, from the field crews, get that data into a file geodatabase, show you how that file geodatabase can be pushed out to a feature service. And then once in a feature service, we can leverage it through Autodesk. We can leverage it through all the ArcGIS applications, web apps, web app builder, experience builder, mobile apps, dashboards, story maps, all have access to the same data. And then we can push it back down to the ground so that our guys who go out in the field, if they need to have any of that data back, we can get it back to them in an easy, seamless way. And then lastly, I showed you how we can take a DWG and just publish it directly into ArcGIS Online and begin to utilize that information and leverage it in the GIS. Thank you.
All right. Well, thanks, Eric, and thanks, Gary. So we'll open it up for questions. You can go ahead and type your questions into the question box, and we'll start with that process. There were several people asked if, in fact, we're recording this webinar. We are, and it will be available back up on the website, typically in about 4 or 5 days. There was another question, probably to you, Eric. Along with the presentation and the slides, will there be some sort of summary of the workflow steps and the different elements that you demonstrated today? And I said, just basically a page of bullets or something like that, really just walking through. Is that something you might be able to put together? Or?
Yeah, I think I can do that.
Okay. And I guess I'd also like to point out, obviously, we've focused kind of on a DOT workflow, but these same processes would really apply across any number of really transportation as well as even non-transportation workflows as well. So one can think about airports and so forth. So along that line, I mean, you've really kind of focused on the technical features, but in terms of the typical workflows within a DOT, how do you really sort of see, is this for, construction inspection? What do you see some of the typical workflows where you'd really want to have this back and forth interoperability between the CAD and the GIS and survey?
Go ahead, Gary.
Yeah, I was going to say, I can take some of that question. You're bringing up a very interesting point, and I'll specifically answer what you just asked and then add another comment. So some of the workflows that are greatly enhanced with this is simply getting the data accessible to different tool sets. So when the design people want to get the survey data, obviously that's probably a fairly well laid out process. This enhances it a little bit by pushing it into a geodatabase first, which opens up the ability to use field tools and for construction inspectors, as you just mentioned, to go out and add data, or just people to add condition or asset characteristics. The surveyor may not pick up the size of the stop sign or the height of the sign. That data could be supplemented by a GIS application where you preserve the accurate survey data and you get more of the characteristics. So having condition and asset characteristic information fed into the designer is important, because it helps know whether you can preserve that asset, you need to replace that asset. So all of that information becomes a lot better. The twist I wanted, or maybe the way I wanted to change the dialogue related to that, is we often get asked, what is in it for the designer in this process, because the data moving out of design and construction over to the operations and maintenance folks there is not really an inherent benefit to the designer per se by having that data move over. So in that instance, they're just being a good corporate citizen in taking the rich data that they have maintained and designed through the design and construction process and helping out their colleagues over in the operations, maintenance, and planning processes by giving them a very accurate, solid inventory of assets. It is a little bit of a chicken and an egg thing, because if you want any of that data, that condition data or things, how they've changed throughout the operation and maintenance and planning phases, you have to get good data into that system so that it's useful and potentially available to the designers coming back on the other side of the asset management lifecycle. So what data do you use for pre-design purposes? Can you use your asset data that's typically in the GIS for pre-design? Well, if you've populated that system with highly accurate data and they haven't messed it up in the operations, maintenance, and planning phases, indeed, you can bring across, again, that asset characteristic, that asset condition data that may be very helpful on the design side.
So there's another question which really sort of fits perfectly into that, and certainly for any number of DOTs in the U.S. that are currently using highways and actually have all of their asset data, the question is, will users really be able to pull in that roads and highways data? Will they be able to pull it into Civil 3D through that ArcGIS connection?
Yeah,
Yes.
it's all
Roads and Highways produces features, and everything that you saw was an ArcGIS feature. So they would be able to pull. Now, if you were doing something like you wanted to be able to touch the route and get specific measure information, that would need to be a button that was added to the Civil 3D interface. So all of that data is being made available, but to do something specific like at this XY coordinate, what is my offset and measure on the route based on the LRS, you would need to create a little tool to do that. But at least we're getting to the point where the data is accessible fairly easily in the Autodesk product environment where you could ask such questions.
Okay. So Eric, this is another question for you. I guess the question is, could you share your Python scripts as well? So that's,
there's
maybe
no state secrets. I can share those.
Yeah. Okay. So, and to the person that asked that question, we're more than happy to reach out to you after the webinar, and that would easily done. Let's see. There's another question. Could this be done through a Python or a style library developed per project? Is the question.
A style. I guess I need a little bit more clarification.
I can. I think the gist of the question, so it probably gets back to the standards for your drawings. Eric wrote scripts that took this specific data design coming from the Trimble survey units to publish them into the GIS layers. If everyone was always adhering to your CAD standards, you could write those scripts one time and have them always work. You could, if the data was going to be formatted slightly different, use different styles and different scripts specific to those individual projects and produce the same exact results. Like you would just take the signs as they have to be in Project A, and you would write a script that writes them into the ArcGIS feature layer for signs, and you would do any of the conversion and manipulation to make sure they matched the feature service in ArcGIS. I think that addressed your question. If not, ask Terry a clarification.
Yeah. So, and from our perspective, I've often been reminded that there's probably never going to be what would be an entirely seamless ability, but certainly our goal, and I think our goal in working with Autodesk and others is, how do we reduce the complexity? How do we make it as easy as possible, really to help facilitate and enable really these information flows? And again, it really is, how do we, if I'm a designer, how do I pull in data from the GIS that's going to really enrich and help me in that design process? And if I'm on the backside, how do I pull in this design in a way that I can update my GIS databases with very accurate data? And that really is the goal. And I think what we've really, in essence, what we were trying to show is, would we like this to be a little bit easier? Yes, perhaps, certainly. But, the technology exists to do this. And, our commitment is that we do think that it's really on us as the vendors to help really reduce those complexities as much as possible.
Hey, Terry, one comment along those lines, because I agree with you. It sounds interesting to come from this seems virtually impossible to this is just completely seamless and zero loss. But I have been very encouraged because of the migration from the traditional CAD design environment into BIM, because BIM is more along the lines of a data model that is similar to a feature class. And by having to adhere to the BIM model, you're getting that standardization enforced. So, and the lack of standardization is what causes all the headaches. So I do have a little bit of hope, maybe more than you do. I'm just an internal optimist, but I'm hoping that as we see more and more of this work conducted using BIM, that we will be more and more standardized and more seamless.
Yeah, and this really does, and I do agree with you. I think the move to BIM and BIM for infrastructure really puts a much greater emphasis on the data. And certainly there are any number of really great project examples from around the world where working with the integration of really CAD, GIS, and BIM, that data really is managed through the life cycle. So let's see. Yeah, so there's a comment, and a person says, in my experience, there comes a point where the technology and tools themselves are not sufficient in being the solution, and it becomes more of an organizational and policy issue. And I certainly, I would not disagree with that. And I think, what both Gary and I are encouraged is, if you went back any number of years, these were the holy wars, the holy wars between CAD and GIS. And I think we're beyond that now. We're really looking at how do we really treat all of these sources as information, and that ultimately, when we get out of the holy wars and we realize that the real goal is how do we plan, design, and construct and operate and maintain projects more effectively, that really puts the emphasis back on the information, the emphasis on having appropriate data models and ways to manage and that data as it goes through the life cycle. So Gary, anything you want to add to that before we close it off?
Nope, I think that's good.
All right. Well, thanks everyone for attending today. We hope this was useful to you. That's, as I said, certainly a very common topic among the DOT, and I'm sure we'll try to do more of these as we go forward. But again, thank you all for attending, and all right. Bye-bye.